Hello everyone, how are you? My name is Juri and today I would like to present you my project for multivariate time series forecasting for a large retail inventory where the client stored about 15,000 items. At the very beginning of the project I had low volume of data, which makes my approach and solution special. I presented this presentation a couple of days ago at one of the ACE webinars. Just very briefly about myself. I'm a data scientist based in Toronto. I have a master's degree in applied economics, and that's why I like to help companies generating economic value. And that's also the reason why time series for forecasting is very close to me. Also, and given my passion for generating the economic value, I found myself in the AI engines for recommender systems. Currently, I'm working with other senior guys, senior data scientists from ACE on a solution for a startup company. And I also have a personal website where I blog about broad-based application of machine learning and keep my profile and works consolidated. So why does forecasting for large inventories matter? First of all the businesses that have a lot of items they sell or use in production, they should consider cost of inventory, which is basically liquidity. For example, in car manufacturing industry, the manufacturers try to maintain something that is called just-in-time inventory, which basically means they want the parts, auto parts on the shelves just in the right time. Talking about, for example, consumer goods, you want your products to justify the demand. If your shelves are full of the goods, you are basically sitting on the money. What you will see in this presentation. As I told you, the data was not perfect for this project. On the other hand, I came up with a very innovative, or not very innovative, but maybe a creative way how to solve this issue. And I rather focus on business side of this project rather than applying only scientific approach. The client of this project comes from retail industry, and he is an international retailer. The items in the inventory experience various seasonal and trend patterns across different products and segments. So some generalization wasn't possible. At the time of the project, the client could only or was only using simple moving average for forecasting and other business intelligence tools. From the very beginning, I was responsible for developing robust machine learning solution and forecast monthly units sold 6 months ahead. It was also specified earlier by the client that forecasting slightly more units sold is better than the overshooting, which means that the client could afford a slightly higher cost of the inventory than not justifying the demand. At the very beginning, I had monthly data for 15,000 items recorded in past 48 months, and three variables, which were units sold, the target variable for the forecast, units order, and units shipped. With this kind of setting and data, there were several things that were possible and that were not possible. So, firstly, it was not possible to create a model for each item individually, which would basically means that I would have 15,000 models for each item. One. It was also not very healthy to rely solely on scientific performance measurements like R squared MSE or AIC criteria. And as I already said, finding some pattern that was generalizable on all items was also not possible. On the other hand, certain things were possible to conduct. For example, versatile time series manipulation, as I will show you in next slide. Also, given that I initially had three variables, I was able to generate or engineer hundreds of them. And since there was no or right approach, I could experiment a lot. And on top of it, since it's a time series data, I applied a unique way of forecasting, which was actually a random forest regressor or any other regressor decision tree based model. And to control the forecasting values in a way that they wouldn't be overshooted or undershooted, I had to control the error, and I calibrated forecasting values. So definitely with this kind of project, you will get your hands dirty. Sometimes you need to think out of the box, and this comes at hand especially during projects when you are supposed to deliver a robust solution, but you are not equipped with a lot of data. Traditionally, time series data is stored in long format, as you can see in the left side of your screen, where time is an index and variables are stored in one column, item ID in the second one, and units in the next. From this kind of setting, I was able to generate a new variable, the fourth one, which is a fill rate, and you can imagine it as a ratio of units ordered and units shipped. It seems that with this shape, with this data frame, which is longer than 2 million rows, it's possible to do a lot of things. But remember, this is a long format and only 5 variables collected for 48 months. Not a lot. But I got inspired in deep learning from time series data, where time series data is actually stored in wide format. In this way, I then managed to have 15,000 rows and 144 columns. With this kind of setting of data in long format, you can generate a lot of features as you would do with any other data, column-wise. So initially, even though I had only 3 variables, I was able to create a fourth one, and given the nature of time series data, I was able to generate over 300 other features. Which was basically achieved by the nature of time series, because I could utilize my creativity and use various locked values and interactions between the variables. So in the end, I was actually able to create segments of the data. By what I mean by the segments, it would be very tough, as I told you, to create or to forecast for each item individually. it would mean it would mean that there would be 15,000 models. But I managed to create segments, and these segments were segments of similar items. But similar items of what? Similar items of the sales, which means basically the products that were very, very, very different from each other could actually be a part of the same segment because they were sold in the same quantities, similar frequencies, and so on. And that's basically how I decided to proceed. One important thing is that the test and train and validation was uh, column wise and not row wise. In other problems where we use tree-based models, we split train and test row wise. But here, imagine that I am forecasting for January 2019, or I am training till January 2019 and forecasting February. That would mean that my test would be February 2020. And remember, this is time series data, so you should use various lagged variables. And your aim should be to overshoot as low as possible, which would mean that for my forecasted values, I created this ratio. I created this metric where I simply measured error bands, meaning how much or how much I was overshooting and undershooting. You can see it here. Basically, I was trying to keep my forecasted values in these free error bands. I also had the negative error bands, and I was actually able to forecast 95% of all predictions into error band, which was plus minus 10%. With this kind of forecasting, you overshoot and undershoot a lot, and you somehow need to control for it. So imagine that I am forecasting for March 2020, which means that last observed month in training was February 2020. And let's imagine that the forecast was too high in the testing set. So what I was actually doing, I was calibrating. I created a ratio of these equation 1 and 2 and multiply the forecasted estimated value for March 2020 by this equation. Here, by the function in white, I mean any arbitrary function, which would be, in my case, mean was the best method. This arbitrary method as an arbitrary function. I also try minimum, maximum, and various percentages or ratio of max and etc. It is a trial and error approach, so you need to try on your own and see what actually performs the best. But the whole purpose of this was actually to lower the overshooting as much to the target. So in conclusion, don't let low volume of data to stop you. Multivariate time series forecasting can be done in a wide format. It's just a little bit exhaustive of coding and creativity and trial and error attempts. I also applied standard autoregressive models like ARIMA or vector autoregressor on long format. And here I combine machine learning with rule-based modeling, but I'm not shy for that since this was the setting was not was very challenging and not usual. It was exciting experience, and here you can actually scan the barcode of my LinkedIn profile where I'm active, and you can visit my website. So thank you very much for your attention, Have a nice rest of the day.